Medicines by Design, MD1, alcohol in the body. Xenobiotics are substances which the body doesn't contain, but which can affect it. They can be divided into three types. Foods provide the molecules which give us energy and keep our bodies well maintained. Drugs alter the biochemical processes in our bodies, for example, changing the way we feel and behave. Drugs which lead to an improvement in health are called medicines. Or poisons severely damage our biochemical processes and cause a deterioration in health or even death. You must have eaten foods, and you would be very unusual if you had not taken at least one medicine. You would have been unwise if you had taken non-medicinal drugs or poisons. But some substances can behave in more than one way. Their effect depends on the quantity you take and on the state of your health. Ethanol is an example. It is a source of energy, but it also affects behavior, and in excess can cause liver damage and even death. Alcohol as a food. Some people celebrate Christmas with Christmas pudding ablaze with burning brandy. This is a reminder that energy is released when ethanol reacts with oxygen to produce carbon dioxide and water. Oxidation of ethanol in the body is more controlled and less complete, but it is still highly exothermic. At the present time, alcoholic drinks contribute to about 6% of the total dietary intake of people in the UK. In the 17th century, they accounted for almost 25% for children as well as adults. The common drink at that time was beer. Alcohol as a drug. Alcoholic drinks make many people feel better for a short time. They help them to relax or cope with stress. Alcohol can make them feel happier and relieve tension, anxiety, or boredom. These effects are all outcomes of a single aspect of the behavior of ethanol molecules in the body. They depress the activity of the central nervous system. This depression of nervous activity has important short-term effects. Drinking alcohol reduces vigilance, slows reaction times, and impairs our judgment. It is largely because of these effects that so many laws have been introduced to control the use of alcohol. This is particularly important in relation to driving motor vehicles. Blood alcohol concentration, BAC, is closely related to the extent of the effects of alcoholic drinks. It is usually defined as milligrams of ethanol per 100 centimeter cubed of blood. The quantity of alcohol needed to produce a particular BAC varies with age, sex, body weight, how quickly you drink, and several other factors. The concentration of ethanol in the blood rises for some time after taking a drink as the ethanol is absorbed. Then it slowly decreases as the ethanol is excreted or metabolized. A unit of alcohol is a convenient measure of how much ethanol is contained in a drink. It is an approximate measure roughly equivalent to half a pint of beer or lager, a full glass of wine, or a single measure of spirits. At present, 80 milligrams per 100 centimeter cube of blood is the legal limit for BAC for driving a motor vehicle. When a motorist who is suspected of drink driving is stopped by the police, a roadside blood test is impractical. A quick BAC is estimated and is needed in order to decide whether or not to take things further. Ethanol, the alcohol present in drinks, is almost the only commonly used drug which is sufficiently volatile to pass from the blood to the air in the lungs. This distribution is an example of chemical equilibrium, and it is governed by an equilibrium constant, Kc, which has a fixed value at a particular temperature. In the body, Kc for this process is 4.35 times 10 to the minus 4 at body temperature. A measurement of the ethanol concentration in the breath therefore gives an indication of the BAC. Ethanol blood reacts to make ethanol gas and is an equilibrium reaction. One of the earliest successful methods of detection, the breathalyzer, is based on a familiar chemical reaction. Orange crystals of potassium dichromate turn green when they oxidize ethanol to ethanal and ethanoic acid. The extent to which the crystals in a tube change color is a measure of the BAC. The Lion alcometer, containing a fuel cell, has replaced the traditional breathalyzer for roadside tests. Oxidation of ethanol is a redox reaction and involves electron transfer. An alternative way of finding the ethanol concentration is therefore to measure the voltage of an electrochemical cell which incorporates the reaction. The Lion alcometer is a cell designed to do just this. An electrochemical cell in which a fuel, such as ethanol, is oxidized is sometimes called a fuel cell. The fuel is being oxidized to produce electrical energy rather than being burned to produce heat. In the alcoholmeter, the cell consists of a porous glass plate in which the phosphoric acid is absorbed. The plate is sandwiched between coatings of platinum or silver, which act as electrodes. Oxygen is reduced to water at one electrode, and ethanol is oxidized to ethanoic acid at the other. The instrument is calibrated by passing different concentrations of ethanol in air through the instrument and measuring the resulting cell voltage. The instrument is set so that a green light comes on when there is no alcohol in the breath, an amber light when a small amount is present, amber and red when close to the limit, and red above the limit. The science behind the alcoholmeter is fairly straightforward, but the technology needed to develop it is more challenging. The instrument must be small enough for handheld use beside the road, must be rugged, safe and easy to use, reusable with a short turnaround time, and reliable. Consequences of the test can be serious for the person being tested. It then has to be marketed and sold. Back at the station, the techniques used for roadside breath tests give a quick, reliable result, but are not used in evidence in court cases, as the instrument does not give a printout at the time of testing. If the roadside test indicates a high level of alcohol, the driver will be taken to a police station for a more accurate determination of BAC. At the police station, most suspects undergo a second type of breath test, where the ethanol concentration is measured using infrared spectroscopy. The driver is asked to breathe continuously into the cell of an infrared spectrometer, and the intensity of radiation absorbed at 2,950 wave numbers is measured. If the driver is incapable or suffers from a breathing problem such as asthma, blood or urine samples are taken by a doctor. 2 samples are taken, one for the forensic service and one for the driver, who can use it to have analysis checked independently. The sample is analyzed in the forensic laboratory using gas-liquid chromatography, GLC.